Welcome everyone to the Western Museum of Flight. I'm Cindy Maka, the director. If you can name it, he can fly it. That's the American test pilot. He earned his spurs in the hostile skies over Vietnam. From Vietnam in the F-8 Crusader to the hostile skies of the futures, he's got it covered. Ladies and gentlemen, pilot extraordinaire, Tom Morgenfeld.
Thanks, Cindy. That's a little over the top for me. I don't ever think of myself like that. Well, thanks for coming out. This is really a big turnout. I guess when you get to be an old historic piece, everybody likes to go to the museum and see the museum pieces. What I'm going to talk about today is flying the YF-22 in DEMVAL. And if I break into acronyms, which we all can in this business, DEMVAL is Demonstration and Validation Phase. It was 1990, a long time ago, and I was lucky enough to be one of the test pilots on the Lockheed side. So without further ado, we'll start right out. This is a little busy, but this is what the Air Force wanted to accomplish with this DEMVAL program. It's basically a risk reduction thing. You can read that. I'm not going to read the slide to you. But they wanted to do anything they could to reduce the risk for producing whatever was going to be the F-22 or the F-23 at that time. The full-scale airplane that we built and Northrop built, no Grumman in there at the time, didn't come in until a little bit later. It was going to be a paper down select, and then the Packard Commission came in and they wanted to see things fly, which is always good for us. The bottom point I really want to stress, though, it was not a fly-off. There was never any head-to-head competition. I will get to a little bit later on how it was done, but there was never a 1v1, send your best guy out, we'll put our best guy out and see who wins the dogfight. That never really happened. At the same time we were doing the airplanes, there was an engine competition between Pratt & Whitney and General Electric. It had started out a little bit before, but it worked out pretty well. I'll explain how it all worked with both our airplanes. The problem is that they drive the design of an airplane pretty heavily. And two different engines in basically the same airframe gave our engineers, and I'm sure it gave the Northrop guys the same problem. A little bit more of a design problem with the airplane. At the end of the competition, the Air Force was going to pick an engine and an airplane in which to put it. Test planning, we were pretty much allowed, each company was allowed to do whatever they really wanted to within sane limits. One thing we were told we had to do, which makes sense, is to get initial airworthiness, make sure the airplanes were all good enough to fly, and then we could demonstrate those things which we thought were very important to our own design and also to the risk reduction. The Air Force had to approve all our flight test plans, but they were very good about whatever we wanted to do, as long as it made sense. It wasn't showboating or anything really crazy. They were all on board for that. This is an interesting part of the competition, the sealed envelope performance. Before either company ever flew the airplane, we had to put down, I'll have to read this off, but various parameters that the airplane was going to meet. Aerodynamics, air data, engine inlet compatibility, the armament system, flutter predictions, all that had to go into a sealed envelope, and then when each team had finished the flight test, they were going to compare the actual flight test data to what we had predicted prior to flying. And that was just going to be a good measure of how well either company could predict what the real F-22 or F-23 was going to look like. We did pretty well on that one, as it turned out. I had to throw that in there because I got two old girlfriends in that one picture. Shows a little bit. The one on the left is obviously the F-117. It is not the box the airplane came in. It is the real airplane. you can see how things have evolved over the years between flat sides, facets, and nice rounded airplanes with in the F-22, B-2 sort of thing. We've come a long way in stealth technology. These are the 5 lucky guys that got to fly the YF-22. On the far left is my best friend, next to my wife, of course, but the best friend I ever had, Mr. Dave Ferguson, passed away a couple of years ago. We shared a lot on active duty. We did a lot of MiG exploitation stuff together, and we kind of came as a team to Lockheed at the same time. The next is me. You'll notice that's back when I was coloring my hair. The short guy in the middle is John Beasley, an absolutely superb test pilot and a lucky guy. He not only got to fly the YF-22, he flew the F-22, and he also flew the F-35 first flight. He's just really and he was on the F-117 team with us too. Great guy. At that time, he was flying for General Dynamics, which was one of the 3 companies we were in partnership with. Next to him is Mark Shackelford. He was our Air Force Flight Test Center test pilot, and just a superb guy. Wound up with at least 1 or 2 stars. One heck of a good officer and a really good pilot. And last but not least, on the far right-hand side of the picture is Willie Nagel. Willie was the operational test pilot. He was an operational F-15 pilot, and he got to fly the F-22, basically doing what we call operationally relevant maneuvers. And he had a really good time doing it. Strange small world story. Willie, after a superb Air Force career, retired and went to work for Airborne Express and had to work for my brother at the time, so he just can't get away from us. Really a good guy. There's a nice picture of the airplane just to show you what the flight controls looked like on the airplane. Nothing beyond what we normally see on modern airplanes. There was a big speed brake in the middle of the back of the airplane, but we had conventional ailerons, flaperons, all moving horizontal tails, a pair of fin rudder combinations and things, all of which are all obviously fly-by-wire to make something like that fly. Very relaxed stability. The unique feature of this airplane is the thrust vectoring, the nozzles. I have one picture of that a little bit later. And we use that to help control the airplane in pitch, and it worked out great. There is a picture of the engine on the engine stand with the thrust being vectored down. It acts, if you think like it, just another horizontal stabilizer, only it can work when there's no air coming across the horizontal stabilizer. It worked really well for us. We put quite a bit of work into the cockpit of this airplane. One of the things we tried to do, this airplane, by the way, I'm sure the YF-23 was the same, it was a good solid 9G airplane. Unfortunately, most of our pink bodies aren't good solid 9G bodies, and we need something to keep us awake during that time. A tendency is for the blood to rush out of your head and you black out and pass out. So we did several things. That's the last 2 bullets there. The first one was color liquid crystal displays. We have those things everywhere, right? But at that time, they were brand new. It was all a new technology. We were a little afraid that they were going to be washed out in the sunlight, which we all know. Everybody try to read their cell phone out in this bright sunlight. It's a bit of a problem. In fact, little sea story. After the program was all over, one of the avionics engineers that was responsible for these displays was coming around and asking us what we thought of the displays. And one of the questions was, how about brightness? And I said, well, we were worried about the brightness, but it was better than we thought, but still not good enough. And we were in cubicles. He went to the next cubicle, which was the Air Force test pilot sitting there, and he asked him the same question. And Mark very politely said, yeah, they were okay, but just not quite bright enough. And the engineer sat there for a second, and he said, that means either my calculations were wrong or you're wrong. At that point, that was all I could do to keep from bursting out into laughter. It was probably all Mark could do keep from jumping up on his feet and strangling the guy. The other thing was those color liquid crystal displays had what they called finger on glass controls, FOG. I changed that during the course of the thing to fist on glass because it wasn't quite as good as we thought it was going to be at the time. Little latency, you'd push the button, nothing happened. Oh, blam, it was up. And also your little fingerprints all over the screen didn't help much. Actually, it worked okay. It was the first try at it, and we were happy to have it. Side stick. Because we had worked with General Dynamics, they had side sticks in the F-16, but that was the first one Lockheed had done. We put a center stick in the F-117. That was a bit of an innovation for us, but it worked out just fine, and it had to be that way for this next item, which is the articulating ejection seat. It was a very interesting concept. Remember I said we're trying to keep pilots awake, conscious during these 9G turns. So the way we decided to do that, does everybody know when the astronauts take off, they get a lot of G's, but they're lying flat on their back, so it's relatively easy for them. They don't pass out or whatever. Well, we thought, hey, if we have this articulating ejection seat, which was nothing more than it could recline. It was hinged around your shoulder, and that's another thing that drove the side stick. The idea was the pilot would have a button on the stick. He could push that button, and it basically shoved your hips forward, and it laid you out pretty well horizontally. So you could then put the bat turn on the bad guy, shoot him down, and then hit the button, and the seat would come back to normal. It was interesting because you don't want to eject from a bad position, but it worked out pretty well in that this airplane, as you can see, it's a pretty big canopy. We can't go through the canopy on that airplane, so the canopy had to be jettisoned before the ejection seat could go anywhere. So we had little explosive charges in the seat that as the canopy was leaving the airplane, it blew the seat into the upright position and then blew your little bottom out of the airplane. Fortunately, we never had to use it. The one thing I liked about it was, does anybody here, well, I do, but it's a very old car. Does anybody have an automobile that doesn't have an adjustable seat back? Well, you could also, we had a little switch on the side that you could change the seat back angle. And that turned out to be just wonderful. You're up for a long flight, you could change the seat back and just a little bit of, you get a little antsy, move it very comfortable to use. That turned out to be the best part of the whole seat. The last thing is the tactical life support system, which is the basically full body G suit that the F-22 pilots now wear. We normally, fighter pilots, I don't know how much everybody knows about this, we wear G suits. They look like jabs or bladders that go around your thighs and your calf, and when you pull G's, they put compressed air in there, and it keeps the blood from draining from your head. And well, this is a full body G suit that we had that. Fortunately, well, let me show you a picture of it. Fortunately, I never had to fly anything because it looked a little restrictive, but it did work good. That is a picture of the YF-22 cockpit. See if I can show you. You can see the color liquid crystal. Well, you can see a liquid crystal displays. The power's not on the airplane. Had a bunch of them, not a lot of gauges in there. You can see the side stick on the right side there. Those triangular, on either side of the seat, triangular pieces that you can see are part of that articulating system that moved your bum forward and your feet up. All in all, really good visibility out of that thing. And there's our young Air Force pilot. As Fergie said, you don't want a picture of us in that thing. We look like green knockwursts. So we put the young hard body Air Force test pilot in the TLSS. He and Willie did the work on that. These were the basic test objectives that Lockheed had set forward. Obviously, super cruise is one of the things we wanted to demonstrate. That's cruising supersonically in basic engine without having to use afterburner. Saves some gas. Agility, obviously it's a fighter, needs to be agile. Weapons bay environment and missile launches. We all have blown across the top of a Coke bottle and you hear that noise. Well, anytime you open an open bay on an airplane, same things kind of happen, and those vibrations can be very damaging to the airplane structure or any of the equipment therein. It's been a big deal with every airplane I've ever flown that had any kind of bay that opened, so we wanted to make sure we had a good environment plan for the follow-on airplane. A high angle of attack, it's another thing. Angle of attack is basically the angle between the relative wind and your airplane. 60 degrees is what we were shooting for. That is a whole boatload of degrees more than most airplanes up to that point in time. We wanted to have it relatively carefree, handling qualities for the pilot, so whatever he wanted to do, he could do without having fear of the airplane departing controlled flight. No cowboy likes a horse that's going to jump out from underneath it. Loads work. We wanted to make sure the basic structure was sound. And then operational factors. We wanted our TAC pilot, Tactical Air Command pilot, operational guy, Willie, to fly the airplane. And he a very experienced F-15 pilot. See what he thought it was like as a fighter, as just in general. We had to make some key decisions along the way. This was probably the biggest one. Sorry, Pete. Pete knows how this works. Sooner or later, these guys will polish anything, and sooner or later, you just got to shoot the engineers and go fly, which we did. We built 2 airplanes, and we had 2 engines. And there'll be some slides that maybe make this a little more graphic, shown later. Ship 1 was our first airplane to fly. It was decreed that that would fly with the General Electric engine. And I believe the YF-23, it was decreed that they would fly first with the Pratt & Whitney engines. Each company made a second airplane and had the opposite engine in there. Anyway, the test objectives we set for the very first airplane were obviously supercruise. That was one of the main design goals that we were given. Agility. And that airplane was designed for the loads and the high angle of attack. First flight, that is a 1990 picture, and for those of us old enough to remember, that's before Photoshop. That is a real photograph, no kidding, rainbow. Little sea story on that. I was the first flight primary chase pilot, safety chase, in an F-15. And Northrop had flown about a month before we did. This is a big competition. We're getting a lot of pressure. Fortunately, I will say, one of the things I've been proudest of the whole time I've worked at Lockheed is that the flight testers were relatively immune or protected from crazy pressure to go fly. Well, we told them the airplanes are like fine wine. When they're ready, they're ready. And we were certainly getting pressure to fly, but our management was happy enough that when we said it was ready, we weren't going to go out and do something really silly. So anyway, we were getting close. And we finally had our first flight day, and wouldn't you know it, bad weather in the Antelope Valley. Happens, once every 100 years. Storms coming through, thunderstorms. Oh, man. Well, I'm out at Edwards Air Force Base, sitting in my F-15 ready to go. And it looked like on the radar that the storm was going to pass on through. So my job was to launch, get airborne in the F-15 and fly around. Our first flight in the F-22, YF-22, was from our plant at Palmdale, fly around the area and then land at Edwards. I was to be the weather check pilot, so there I blast off. As an aside, these airplanes, and it doesn't show up too well in any of my pictures, they have a flight test probe out in front of it. They aren't heated. You never want to fly those through ice or rain or anything, because that's bad juju. So bear that in mind. So Aviator Morgenfeld gets airborne, look around. It looked like the storm had been moved out to the east. It looks like it's breaking up. A lot of counting on this flight. So I said, get ready, launch them, it's good to go. So Fergie fires up, we come around, and just as I do the airborne pickup at Palmdale, that thunderstorm moves back. And I'm thinking, oh, it's raining. I thought, I've just killed my best friend. I didn't mean to do that, Ferg. At any rate, our photographers, you can see the result there. We managed to get a very nice picture with the rainbow. Ferg made it all the way to Edwards, long distance flight, and it all turned out really well. And I'll get into a couple other things with that one later. Anyway, that is, believe me, the first flight of any airplane is super exciting, and the weather made this one a little more exciting than we wanted it to be. Early testing. You always like to get things done as early as you possibly can within reason, I guess. So the very first one was our wet runway operations. Normally, you save that till a little bit later in the program because it's wet runways get slick. You never know how the anti-skid brake's going to go. You're going to run off the end of the runway, whatever. Anyway, Ferg took care of that on his first landing because while the storm had passed through Edwards, the runway was pretty wet. You might even see that in the video I've got a little bit later. Another early bit of flight testing we did was some single engine work. Flight number 3. Again, I'm the primary chase and come down for an airborne pickup on takeoff. And at that point, we had not selected the afterburner for takeoff and hadn't planned to. As I come on Ferg, all of a sudden he kind of slows down and then blammo, lights the burner and away we go. Thinking, what in the world just happened there? Well, as it turns out, he lost an engine right at rotation. These engines are so smart, they know when they're sick, and they will shut themselves down. I think that's because the engineers want to look at the smoking hole and say, well, my engine was okay. I don't know if that's true or not. But at any rate, what had happened is I believe it was a fan speed sensor had failed. It thought it was going to overspeed, so it shut down at a very, very bad time. And Dave, wonderful presence of mind, lit the afterburner and flew on out. So flight number 3, we got some single engine flying qualities out of the way. Later on, not a week or two later, we did have alpha and beta is angle of attack and side slip for those that aren't into flight control stuff. And we did have the system go to backup gains at one point. Again, no problem there. And the very last one, we were trying to do a lot of flying in a very short period of time. We were told we were done by the end of 1990. And the winds came up pretty strongly at Edwards, and we wound up getting a 20-knot crosswind component. That's another thing you generally back into a little bit later in the history of flying an airplane. But the airplane took good care of us, no problems with any of that other than, I think Ferg probably was a little alarmed when the engine quit on him, but other than that. That is a picture of our ship number 1 with the spin recovery parachute on the back. I don't know if anybody's familiar with that, but it's not a king crab attacking the airplane. It is a big parachute canister back there. The idea being, if for some reason you should depart control flight and get into a spin that for some reason you cannot recover using whatever airplane controls you've got, that is a big drag chute on a very long tether. And you have 2 ways of getting out in the cockpit. You blow that out, it acts like a big speed brake, if you will, gets the airplane pointed in the right direction, you get rid of the chute and fly away. Probably relight the engines and fly away. Anyway, that's what that was for. The only testing we ever did with it was on the runway, just to make sure that it would deploy, and it did fine. Never used it in flight. That is kind of a neat picture. It's taken through a telephoto lens from a ways away, so it looks a little funny, but that is the YF-22 at 60 degrees angle of attack. That is just a boatload of angle of attack, and the airplane was very nicely behaved at all that. Ship 2, which was my airplane to look after. Dave had Ship 1, I had Ship 2, the one with the Pratt & Whitney power. As I like to point out, the airplane that was finally selected was my airplane. But anyway, I'm pretty kind about that. One of the things we had to show also, obviously, we wanted to show we could super cruise. A little more of a challenge. At the time, the Pratt engine didn't put out near the thrust that the General Electric one did. So it took us a while to be able to super cruise. I think basically, I believe Northrop had the same issue. They wound up choosing the Pratt & Whitney engine for other reasons, I would imagine. But anyway, we used Ship 2 for weapons bay environment and missile launches. And then that was the airplane Willie used to do a lot of his operational kind of flying. That is an AIM-9 Sidewinder being launched from the airplane, from one of the Cheek stations. Stealthy airplanes have to carry all their weapons interior because if anybody can figure out how to make a stealthy bomb to hang on the outside, come see me because we can make a lot of money off of that one, right? It has to be carried inside the airplane. So we wanted to show two things, that we could deploy weapons from these bays, and also that the acoustic environment, the vibrations we were talking about before, were acceptable in the airplane. So that is a Sidewinder coming off the side rails. And that was a good day for me, flying over the water again. Hadn't done that in a long time. This was our first AMRAAM or AIM-120. That's a radar-guided missile, and that came out of the center bays of the airplane. The airplane was designed with 4 of these missiles right across the bottom, so you open the door, any missile off of any station, anytime. And there's young Willie having the time of his life in doing some loops and whatever else in the airplane. It's just a real pretty picture. I think that was on the cover of Aviation Week at one point, but I stole it anyway. Not above stealing things like that. There's a family portrait of the 2 airplanes over the dry lake bed at Edwards. Basically the same outside airplane, just different engines. Interesting, most of the time you see either 2 of the ATFs flying, either ours or Northrop's. Generally speaking, the airplane on the wing will be the Pratt & Whitney engine airplane, because their control, these engines are all software controlled. Their control of the engine was much better, and it made it a lot easier to make very precise, small, smooth power changes, which we all like to do when we're in formation. The General Electric engines were super thrusty, but even sitting there, well, I'm sure you probably remember, Pete, you'd hear them sitting there at idle before they ever taxied out, and they just go, it just never would find idle. And in flight, there was a lot of lag, and the thrust control wasn't quite as good. So most of the time, if you see 2 of these babies flying together, you can pretty well guess that the Pratt powered one is on the right-hand side or on the wing. I had to put that in there. We're in Northrop country, so we call that sleeping with the enemy. We had a couple days. We wanted to take the pictures just for historical purposes. Two very pretty airplanes, 2 very different airplanes in shape. In fact, being somewhat of, I'm sure everybody here is an airplane aficionado. If you were to blindfold somebody, open them, that didn't know anything about these airplanes, and you say, okay, who built what airplane? I would be willing to bet that without any prior knowledge, they would say Lockheed built the YF-23 because it has a lot of SR-71-ish look to it, and that probably the Northrop McDonnell Douglas team built the YF-22 because it's got a lot of F-15-ish kind of look about it, but not the case. Anyway, couple of real pretty airplanes for sure. This is our flight history. You can say either we got lucky or really good. The only thing, I mean, it's an eye chart, but the thing I want to show you is the dotted line is what we thought we were going to be doing for flight testing. And both airplanes turned out to be wonderfully reliable, predictable, and the solid line is what we actually flew. We flew 3 months and got 74 flights in that time, which for a brand new airplane is, at that time, for sure, unheard of. A couple of points, and I flounce around there, but we did air refueling on the first airplane. The first flight of ship number 2, which was my baby, happened a month after the first flight of ship 1. We went on all the way up to the final point up there was one of the most memorable days of my flying at Lockheed. I had not flown Ship 1. I was completely immersed in getting the weapons off of Ship 2 and whatever. So Ferg said, Tommy, you need to fly Ship 1. So here it is, the last day. Well, we didn't know it was the last day. We thought it was going to be close. It was the 28th of December, and we knew that as of the 31st, we had to stop flying. So what we had, on that point, we hit maximum Mach, maximum altitude, and maximum G all in one flight. It was breathtaking. Went out way east of the Colorado River. There's a big, long supersonic corridor comes over Edwards. And I will tell you here that of all the Mach 2 airplanes I've ever flown, this is the first American airplane that could get to Mach 2 and use it tactically. And in the F-4 and other airplanes I've flown, you can get to Mach 2, but that pretty much has to be what you want to do on that flight, because at that point you're out of gas and whatever. Anyway, came back in, started out, went to Mach 1.8, did some test pilot stuff in the airplane. Said, okay, you're cleared on up. We went on up, got to Mach 2, and by this time, Japan's coming at me. And I think, okay, well, here we go. We're going to get this last test point at Mach 2. I pulled back on the throttle to stabilize at Mach 2 because the airplane was accelerating like mad. Pulled back on the throttle and thought I had it, and it crept on up to, 2.03 or something like that. I thought, I've blown it, but we at least got to Mach 2 of the airplane. Came back, throttle back, got the max G. And Paul Metz, who was the chief pilot on the YF-23, we saw a video where he had come out of the airplane and said something, well, we have the highest flight, they'd just gotten their max altitude. We have the highest flying ATF. And I said, well, take this, Paul. I was supposed to be at 50,000 feet. I went up to 50,500, just little things you do, right? Little things you do. Anyway, that was a high point of my time in the airplane. It was just a wonderful, wonderful day. That's the statistics we have. The number 1 airplane, it flew a little bit more. Got the 60 degrees angle of attack, 82 knots. Trust me, that's slow for a big, heavy fighter. I like the little greater than Mach 2, 50,000 feet. And ship number 2, we spent more time getting the weapons off that. We only went to 20 degrees angle of attack with it, but that is still quite a prodigious amount of being able to slow down and turn. And if you notice, we never did take that out to Mach 2 either. We were too busy with the weapon stuff. This is not the sharpest, not your eyes, it's the video. But this is a quick video on our flight test program, and hopefully, there we go. This is Fergie manning up for first flight. Hoping that it wasn't going to rain on him. But you'll see in a minute. It wasn't the most pleasant day to fly. $1990 seems like yesterday, but that's. How old were you then, Brian? Come on. There's the slow motion kind of lift off. You can see in the background, it isn't the most pleasant day to fly. If the film was a little better, you can still see the spray coming up off of some of the wheels while he did his wet runway landing, but we got it all off okay. These are the 2 missile launches we did. It's out over the Pacific Ocean there. Missile just went off stupid and into the water. We just wanted to make sure it could get rid of the airplane, get clear of the airplane without hitting anything. Just some more formation pictures. For some reason, that tail always makes me think of an earwig. I'm not too sure why that was, but it looks a little bit pointed. There's some more pictures of the 60 degrees angle of attack. And it's not a great big deal these days to get an airplane to 60 degrees angle of attack, but to do it within the first 3 months of flying in the airplane for the first time was a prodigious task. Okay. So there we are. What did the F-22 contribute to the YF-22 contribute to the F-22? It allowed the Air Force to rewrite their spec with maybe a little more knowledge, figuring out what would be a good one. We got a nice balance between LO as low observability, balance between that and the speed, how the weapons all worked. We got rid of some bad ideas. The cockpit was one of them, not the color liquid crystal fist on glass thingies, but we decided not to do that articulating seat, probably from a complexity standpoint, but I tell you what, if you spend a lot of time in an ejection seat, you wish you could move that back just a little bit. Anyway, it was not in there. DEM valves, we call it demonstration validation, was a first refinement of some really good ideas. IVSC is what we called our integrated vehicle subsystem controller. The computer controls all sorts of things, everything from the weapons to the air conditioning, management of the hydraulic systems. All that was controlled by one little, I used to call it a 4-letter word. It worked out okay for us. So, and lastly, the thrust vectoring worked out really good. Turned out that, as we all, anybody here seen the F-22 air show? Pretty impressive, and that thrust vectoring really works great. And it was the first iteration of our aerodynamic characteristics. And as anybody knows, it's always easier to take something somebody else has built and improve it a little bit than it is to design it right up front. So we took the aero characteristics of the YF-22 and they shaped them from there to come up with the F-22. This is, these slides from now on, I've stolen from my good Air Force buddies. This kind of compares both airplanes, or at least what happened during the test program. First thing we did, both teams demonstrated good flying qualities of a low observable airplane that also had to be highly maneuverable. It's easy to build an airplane that's very low observable if you don't intend to do a lot of maneuvering. So they tend to be mutually exclusive sometimes. Both teams did that. We both did supercruise. We did high angle of attack, and the Northrop team did not. Systems, could the airplane be supportable? The only thing we did there was they just took records while we were flying all the airplanes just to see how the reliability was, to see if we knew what we were doing, and that worked out pretty good. It wasn't a big deal, though. Weapons, our team launched the 2 weapons, and lastly, the cockpit was highly leveraged off of what we had. We were the only team that took the steps like the TLSS and the articulating seat. Part of them good idea, part of them not, but we at least tried. We got good credit for that, I think. Another eye chart. Basically, the top thing is what the Air Force was looking for was maybe a ground prototype of the avionics that was going in the airplane, what we call a pole model, which is a full-scale model for measuring the radar cross-section. Not a whole lot. What both teams managed to do was build 2 prototype airplanes. We flew with 2 different engines, kind of another bit of difficulty in there. Both teams took care of their high-risk technologies, demonstrating them. Each team built an airborne lab rather than just having the avionics that are going to go in the F-22 or F-23 demonstrated in a lab someplace. Both teams put them in flying aircraft, big airplanes, so you can work on stuff, and demonstrated that. A lot of trade studies went on, obviously, and we did full motion, man-in-the-loop simulations, and a lot of maintainability work was done on them. Both teams went well above and beyond what the Air Force basically wanted. There's the stats side by side, YF-22 and YF-23. I'll leave that up there for a while. You can see how we swap each engine. The first airplane for both teams flew with one. We flew with GE, and Paul flew with the Pratt & Whitney engine. It's funny enough, the Pratt & Whitney engine was ready way before the General Electric, and we said, come on, well, we're going to fly that airplane first. That was completely unacceptable. We were told, no, it's going to sit down there where Lockheed, you have to fly with the General Electric engine first. So you can see we flew 74 flights, 92 hours in 3 months, starting from a brand new airplane. It was a lot of fun. There we go. End result, particularly from the Air Force standpoint, they felt they got an outstanding performance from two really good teams, the Lockheed General Dynamics at the time and Boeing team, and the Northrop McDonnell Douglas teams. Both teams, I think, the most telling thing of both teams built two airplanes with two different engines, went out there and in the course of 3 months showed everything they intended to show, and we didn't bend a piece of metal the whole time. We had a couple eye-openers, but neither team had any big problems. It was stunning to me. I think that may be the first time I can ever think of in aviation history that two brand new airplanes with two new engines did so well. Full credit to both teams on that one. And that's the last I have. Anybody, one last picture of the airplane up there. Any questions? I can make up an answer. Yes, sir. Everybody hear the question? I can repeat it. You said when you're flying at that at 60 degrees angle of attack, how much is that you flying the airplane and how much is it the electronic controls flying the airplane? The answer is both. You control the airplane. The electronic controls simply make the airplane do what you've just asked it to do. Although when you get to these really high angle of attack, it rolls around a velocity vector, so sometimes a roll can look more like yaw. It gets a little weird up there. But yeah, you move the stick. You can't, in a fly-by-wire airplane, you can't tell what goes on between the stick and what happens with the airplane. You don't know whether they're push rods and bell cranks like my Mooney, or whether they're electronic flight controls like YF-22 and YF-23, where the magic just happens. These new airplanes do crazy things. The computer knows how much motion it can get out of any control surface, okay? In fact, this was a problem we had on the X-35 at the start. The airplane is so smart, it knows how much roll it can get from horizontal tails differential, it knows how much roll it can get from ailerons moving or whatever. So when you move the stick, it said you wanted to roll at a certain rate. One day it would move the horizontal tails, and the next day it would move the ailerons, and it rolled just fine, but we had to put some logic into that. So the answer is you are controlling the airplane completely. You have no idea whether there's electrons or push rods between you and the rest of the airplane. They fly very nicely. In fact, it makes it very easy to fly, very, very easy to fly. Pete.
Where are those two airplanes now?
Where are the two airplanes now? I'm happy to say ship number 1 is in the Flight Test Museum at Edwards, and ship number 2 is no more. That was the one we had. I had the accident after this was over, after the down select the following April, we started to fly the airplanes again to gather more data, and I had a nasty crash in the second airplane, and it's been used as a pole model, I think, but it's been basically disassembled. Yes. Question is, do we have a type-specific simulator beforehand, and how much time do we fly? I don't log simulator time, but it was hundreds of hours. A good part of years or so spent in the simulator. The simulator was an engineering simulator, not the kind of simulator you go to flight safety. Okay, it wasn't all the switches and everything weren't in the right position, but the stick, throttle, and seat position, everything there was absolutely representative with a visual. We used that to develop the handling qualities of the airplane. We probably, I would guess, if you want to guess, probably had about 300 hours each in the simulator before we ever got to the airplane. Yes, sir.
You talked a lot about the performance at that point.
Okay, the question is, I talked a lot about flying the airplanes. Did anybody work on the low observability characteristics? The answer is each team built what we call a pole model, and all the low observability data were gathered on those. The airplanes themselves, we didn't do any real measurement, but the airplanes the models that they use were one-to-one scale. They were very carefully done. And that was done at a radar cross-section measuring facility elsewhere. Yes? The question was, why did they pick the Pratt & Whitney engine instead of the General Electric? I don't know. I was not, none of us on either team were obviously part and parcel. That's all an Air Force decision. I can tell you what I think. Number one, I had mentioned how the General Electric engine was, the engine controls weren't as near as refined as the Pratt. Another thing being, my degree's in internal aerodynamics, turbomachinery, so I'm kind of a jet engine geek, okay? The cooling techniques that they used for the cooler turbine blades, hollow blades, whatever, they were pushing the limit. And in fact, the day I flew that last flight, I think one of the reasons it was such a goer, at that point I think General Electric kind of knew that it might not turn out well for them, so they thought the one thing they could do to save the day was turn up the crank more. Yeah, I mean, jet engines, the hotter they get, the shorter they last, and so that's the trade-off. Pratt engines have been, oh, cheapers. I don't mean this to blaspheme anybody. They've always been a little more agricultural than General Electric engines. The J79's got a lot of movable guide vanes. I got lots of time. My beloved Crusader had a Pratt & Whitney engine, and a little simpler, but got us back every time. So I think that's why. I can't tell. Those two things that they felt that maybe the 120 engine, the 119 engine was just a little too go-y, a little too high risk. But that's just me thinking. I honestly don't know. There was a question in the back. Yes? That's a good question. She asked, when I had the accident in the airplane, did I have any, obviously the airplane never flew again, did I have any big damage? Nothing too badly, and it gets back to that, interestingly enough, it hit hard. It hit hard, and so much so it even bent the pitot tube down, and it tore the left engine loose from the engine mounts. Give you an idea of what started, it's burned pretty badly, and that broke the main fuel pipe. So it hit hard, but the thing that I think helped me a lot was the fact that articulating ejection seat, because I'd been airborne for quite a while, I had it relaxed, or I had the seat back down quite a bit, so instead of taking all that impact right up my spine, which can tend to break discs and everything, I took more of it along my back this way rather than up my back, and I credit that with the thing. I had some internal problems for a month or two afterwards, but nothing mechanical. Question in the back? The question was basically, these airplanes now, is that information being plowed into airplanes that are coming along? And yeah, we always do that, and there is no parochialism in there. I'm sure everybody shares data from F-22 now. I understand, I mean, I read the same magazines you do. There may be a new fighter out there someplace, and I'm sure that every bit of information about that little beauty is been folded into the new airplanes. It's just the way we do business. Okay. The question was, can I elaborate on whether single engine or two engines? That's a heck of a there probably is no right answer to that. If you look into the safety data, it's kind of hard to justify two engines, meaning to have them. I mean, that's one of the things that sold the YF-17 F-18 to the Navy was twin engines. I have spent the vast amount of my time in single engine airplanes, and to be honest, the only nasty engine failures I've ever had have been in multi-engine airplanes, so I've been pretty lucky, I guess. It is hard when you look at the safety data, though, to justify that. The F-35 is a single engine for one reason and one reason only, and that's the laws of physics. We could not figure out a way to put two engines in the airplane because it makes them quite a bit heavier, quite a bit bigger, and there was just no way we could do the vertical takeoff landing thing with twin engines. So that drove it. Another thing these days, engines are hugely expensive. So another reason why you see new airplanes come out single engine. We got, the F-35 has, what, 40,000 pounds of thrust out of one engine. I mean, I've been in flights of 4 that didn't have 40,000 pounds of thrust total. So as much as they cost, they try to go single engine. I have no problem, and I don't think most pilots have a lot of problem with single engines. They're so reliable these days that you can argue it both ways. Obviously, you've been the other way around. You had an engine failure, a couple, and the other one brought you back. So it's kind of one of those arguments that is hard to win one way or another, depending who you're talking to. We're crusader guys, right? Alone and unafraid, and over the water, single engine. The only engine-related one we had that I ever saw go in was a throttle disconnect. But hope that's an answer. It's not much of an answer, is it? Yes, sir. I have no idea. Each team was allowed to do whatever they wanted to. I truly believe that Northrop, they quit flying a couple weeks before we did, maybe middle of December sometime, and we kept going. Both teams, I would have to say, flew just as long as they felt they needed to demonstrate the objectives that they'd sent out. They obviously thought that they had done that. I don't know of any other reason. There's no problems with the airplanes that I knew of. They just, I guess they just figured they'd done what they wanted, they set out to do. It took us maybe a little bit longer, but we flew about half again as much as they did. Yeah, his question was, did the government say you have to do these particular things, and that's why there's a difference in the hours flown? No. All the government ever told us to do was we had to do a reasonable envelope expansion just to make sure the airplanes were airworthy, which you always do early on, and everything beyond that was strictly what the teams felt they needed to do for risk reduction and to hit the goals that they wanted. There was no pressure from the Air Force to do anything beyond that. So we just flew what we wanted to do, what we'd intended to do to answer all those goals that we'd set for ourselves. I can only guess that the Northrop team said, hey, we set out to do this, we've done it in spades, we're happy, and that. Yes, sir. Question was, how did I feel on the first flight of the YF, my first flight. In fact, my first flight, I never flew ship 1 before I flew ship 2. So when I flew ship 2, that was literally both of our first flight. Scared in the fact that so many people work so hard to build these things, and you are a single point where if you goof it up, that was my, you don't want to fumble the golden football, put it that way. And so the pressure I was feeling, and I'm sure Fergie felt the same. I did the same. I did the first flight on the X-35. Same thing. The pressure you feel is you see all these people lined up there. They have thrown so much of their life into this airplane. Everybody just counts on it doing well. So that's the pressure I felt. to be honest, you train so much in the simulator before that it's all pretty much what you expect. Airplanes are always just a little different than the simulator, not terribly so, but yeah, no real fear other than I don't want to screw it up for people like Pete that have been working on this thing for years. So. That's it. Anybody else? Thank you. Appreciate your time.